Hi, this is Henk Akkermans and this is Supply Chain Dynamics Chapter 4. Sysdea Gameplay 5, Historical Behavior. Spread throughout this model are graphs that show the historical behavior that with this history-friendly simulation we try to emulate. So the behavior in this model isn't precisely the way that our historical data suggests that it was, but it comes close. So what is pretty much precisely the way it was is the historical sales rate, which is shown up here. Of course, this is original. The data here are in monetary values, but the signal is one where in the beginning of 2000, this is in months, beginning of 2000, if we index it at 100, then you will see that in the summer of 2000, beginning of 1999, in the summer of 2000, actually there was a peak, a monthly peak, more than 100% higher than this, and a weekly peak that is. And then sales tapered off, but please note that it's higher than 100% even later on. But this is the big signal that we send, the pulse more or less, or the step function that we send through this system, a big test case. Now historically, what else do we know? Then we have to move to this side of the model. We know that the peak period there resulted in a production rate, which we have here also, of starting at this level, going up and up and up, and then all of a sudden collapsing very much in a very short period and going down. And this collapse, mind you, is later than the peak in demand. So there's a delayed response of a few months here. What is much more delayed in its response is inventory, because inventory really peaked in 2001. In itself, that sounds logical enough, because it takes some time to produce after you've ordered. So even when the orders go down for a while, you still have stuff coming out of the pipeline, but the effect is too big for that. And one of the assumptions in the model is that for a while it took the semiconductor industry some time to understand that really they couldn't keep producing what was needed to make the fixed costs. So in production planning, capacity plan, there is the option of producing at least 75% of capacity. No, the rules of the game had changed and they had to work this down. Even then it's difficult to reproduce this bulk of days worth of inventory. So that happened at the end of the system. In between, well, what we also know is some data on capacity utilization. We know anecdotally that in 1999, the first 12 months here, utilization was high, but in 2000 it was really as high as it can be. And from here on, we have historical data. We have this massive drop to just 40%, unprecedented at that time in the industry, and then a gradual recovery. We know that also, so we can emulate that as well. There are some performance indicators that we can that we also have data for. The RLIP, the requested line item performance, so how much customers, what percentage of orders that customers ask for is actually accepted. And you see that dropping almost simultaneously with the peak in demand in month 22 or 23. So an immediate drop in performance, the same for the CLIP, the confirmed line item performance, which goes less deep because this is only the products that you said you could supply, and in the end you can't. So we have a very quick response in performance indicator there. We have a somewhat delayed response in the production rates, and we have an even more delayed response in the inventory. And the challenge now becomes to make a model that not only in terms of structure behaves the way that is shaped the way that we know that semiconductor was shaped, and that the people within semiconductors tell us it was shaped, but also in behavior mimics history close enough. And as you can see throughout the model, that often is not so bad at all. So that's the comparison between historical behavior that we have to start off our model analysis.